Connected in 3D, Real-Time Solutions and Digital Twins podcast with your host, Ashley Crowder.
Hi, welcome to Season 2 of Connected in 3D, Real-Time Solutions and Digital Twins. I'm your host, Ashley Crowder, co-founder and CEO of Ventana. This season, we'll be diving even deeper with manufacturers across industries on how they're using and scaling 3D to improve ROI for their business. And today, we're lucky enough to have Michael Hayat, Senior Project Manager at Northrop Grumman, who will be sharing insights on how they deployed enterprise-grade AR systems on Northrop Grumman's F-35 center fuselage integrated assembly line. So Michael, thanks so much for joining us.
Thank you, Ashley. Pleasure to be here.
Yeah, so tell us a little bit more about your role at Northrop and how you became involved in deploying AR systems for the assembly line.
Right. So right now I'm a senior project manager in our manufacturing technology team at Northrop. And I joined in Northrop in 2021. I came from an airline IT background, so I fit pretty well in that role. And my role is to evaluate and integrate new technologies for assembly lines, technology that could benefit the efficiencies or the cost of the assembly line of the assembly, and then implement those digital systems and the physical devices that come with them pretty often. So we often conduct like feasibility, proof of value studies, ROI analysis, return on investment analysis, and then we transfer our technologies to production. So that's what our advanced manufacturing technology team does.
That's awesome. I love hearing about this because, one of my first internships was actually at Northrop Grumman as an industrial engineer. So like the measuring efficiency and the assembly line and all that, like it's so wild that I could have been on your team if I stayed there.
Yeah, it would have been great.
Yeah, but what drew you to the intersection of digital twins, augmented reality, and advanced manufacturing? I know you guys have this whole digital ecosystems now, which definitely wasn't there when I was an intern.
Yeah, so what drew me to the intersection of these technologies, I must say, I think I was at the intersection. I just found myself at the intersection. I had an airline background previously to Northrop. I worked in as an IT project manager for a big commercial airline, and I oversaw aircraft maintenance systems. So I had the project management background, the IT and digital transformation background, the aerospace and airline, like aerospace industry and aerospace maintenance, because maintenance is very similar to manufacturing. I mean, so I had that background also, and I also checked the AR bugs because at my previous job we did a proof of concept on serving repair instructions via AR to maintenance technicians. And that worked pretty well. I mean, it was on HoloLens 1. I'm not sure if you remember that headset. It was the precursor of the HoloLens 2. And it was pretty limited, and the field of view was pretty limited. You had to shift left, shift right, or read documents looking up and down. So that kind of remained a POC, but I had that experience in my background, and that's why I'm saying I was at the intersection of all these technologies and those skills, so that made it a perfect fit for Northrop's advanced manufacturing technology team.
That's awesome. And with Northrop Grumman recently deployed AR work instructions for the F-35 center fuselage assembly line, can you walk us through the journey from concept to production? Like, how did that become a reality?
Yeah, it is a journey. So let me talk about how AR came to the F-35 assembly line. I can talk about the F-35 and then the assembly line, and then how AR got there. So the F-35, as you may know, it's as you know because you work there. It's one of the most advanced fighter jets on the planet, and it has three variants. If you remember the three variants, we have A, B, C's. A is the CTOL, the conventional takeoff and landing. B is the STOVL, short takeoff, vertical landing, and C is the aircraft carrier version. So Northrop is a principal partner in the industry team who make the F-35, and we developed and produce all three variants. So it's pretty complex. We produce the central fuselage of the aircraft. It's a very complex portion of the aircraft, and we produce all three variants, which makes the manufacturing even more complex. And it's hard for technicians to go from one variant to another, and next day is a different variant. That's why AR was very is very helpful. So the assembly line now, it's really an extraordinary facility. You've been in Palmdale, right? I mean, you interned in Palmdale, yeah.
Yeah,
So
a
it's
lot. I mean, this was 20 years ago, which is crazy.
yeah. So
So,
it may have changed a little bit because it changes all the time, but it's a huge facility. Like it's 500,000 square feet. I think it's as big as 9 or 10 football fields. Just the assembly line. It's
yeah.
filled to the brim with like cutting edge technologies, and this facility produces one F-35 center fuselage every 30 hours. So you can imagine the clip of production.
It's
So,
amazing.
of course, Northrop is always optimizing and improving efficiency and improving affordability on this incredible assembly line. So now, how did AR came to that? I mean, the AR is one of the most recent high like cutting edge technologies we deployed on the assembly line. The way it looks like is the technicians wear a headset, and then they can see holograms of parts they need to assemble on the aircraft before they even assemble the part. The part is already there as a hologram. They can see text floating in air, like with instructions. They can see visual aids. In air, we can point to things or highlight things or even animate parts of the aircraft to show the assembly path. We can show videos. We can show a lot of visual aids at the product. So that's how we ensure like really proper installation, proper assembly, and high quality.
Yeah, I
So
mean,
yeah.
it's such a great use case to be able to have people have their arms free, wear the headset, be able to visually see what they need to do, especially with alternating between the three different types of fuselages, each day. Because I imagine it's hard to remember everything. Now, you guys are still using the HoloLens. Why did you all choose the HoloLens to start? And what is your kind of plan now that HoloLens is going to be sunset in a couple years?
So yeah, we picked the HoloLens. It's a really great device that fits really well with our use case. I can't. We are looking at the future and future plans. I can't talk to specifics about our future plans, but I can tell you how we really love using the HoloLens too. First, like compared to the old HoloLens one, it's a whole other device, a whole other ball game. The field of view is great. Like you said, it's hands free. Um, it's self-contained. There's no wires connecting to any units on your waist or anything. And it fits really well in the Microsoft ecosystems. It runs a Windows operating system. Like a PC, can take several user profiles. So each technician have their own profile of the device. They can authenticate it through their iris. Integrate with our enterprise Active Directory. Right now it's called Entra ID, but it's the same as what used to be Active Directory. And in an industrial setting, the HoloLens is also rated as safety glasses, so it makes a great difference. We tried other devices, I'm not going to mention brands,
Mm-hmm.
but that don't qualify as safety glasses. Or if you have prescription glasses, you need to buy special lens to adapt on your device. HoloLens, you can wear your personal glasses or prescription glasses and wear the HoloLens on top of them. So very convenient and very easy to integrate in our digital ecosystem.
Yeah, no, it makes sense because HoloLens really is the only one to date that's optically clear, which is definitely a absolute requirement in the field in a dangerous environment like a manufacturing assembly line. And so I know there's a number of players out there trying to replicate that and kind of fill the gap in a couple years when it's gone. But that's essential for anybody listening, thinking about doing a similar type of AR experience on a manufacturing line, having an optically clear headset is really important. So beside the hardware, you set up a lot of different software to help make this scalable for the organization. One, you mentioned integrating with Azure AD and everything you have with Microsoft products. Talk to me a little bit about the integration of Scope AR's WorkLink platform and how that streamlined the management and distribution of the AR content.
Sure. I think, yeah, as much as we love the HoloLens, we also love the Scope AR WorkLink software because it's a really excellent fit. It's the best possible fit with our use case. The WorkLink product is geared towards serving work instructions to technicians. Of course, they serve different industries. We're in the aerospace industry, but for us, it was a perfect fit from a use case standpoint. And it's also a no-code platform. So our manufacturing engineers, they are very familiar with manipulating 3D models. They're not coders, and we don't want them to be coders. We don't want to distract them and waste their time coding, because the minute you write a line of code, you have to debug. There's going to be a bug somewhere.
Yeah.
So Scope AR with their
all
yeah, and you have to go, and then you have to go through quality assurance for the code itself and everything. So that's not a good proposition for our use case. So we really love that WorkLink is a no-code platform. Our manufacturing engineers, they are very much used to manipulating 3D models. So they fit right in they hit the ground running in WorkLink. WorkLink also accepts a variety of input formats for 3D models, so we could seamlessly integrate with our digital ecosystem and reuse our existing 3D models to build AR work instructions. And it also outputs to a wide variety of devices. So HoloLens is one of them, but you can output to an iPhone, to an iPad, to other devices. So that's what gives us good comfort that we can easily reuse all our AR work instructions on any platform if we need to migrate from the HoloLens to a different platform. By the way, HoloLens I think it has quite some runway. I think Microsoft is going to end support in 2027, if I remember correctly. So we still have some runway, and pun intended, to completely replace it.
Yeah, but I know how fast the enterprises tend to move. So
there's time and there's also different use cases. Like if you really need your hands-free, HoloLens is ideal because you need to manipulate tools maybe or parts. If you're more in an inspection role and you just need to look at things and write up and make write-ups, you don't need to carry so many tools and parts. A tablet could be sufficient to see AR and compare the AR of as designed to the physical as built product and then perform quality assurance.
Definitely. And that's great that Scope AR is multi-device, because we talk about that a lot with our clients, of making sure you choose something that can also be mobile, desktop, tablet friendly, just because you never know when you're not going to have a headset, someone doesn't want to wear it. There's a lot of different use cases. And then you also mentioned...
Sorry, one more thing about the software and the company. So, like I said, the Scope AR WorkLink is very powerful. It can do a variety of lighting, texture, orientation. I mean, it's very easy to manipulate 3D objects. So not only we put the 3D model in there, we also put the instructions, the text or graphics or whatever. So when you author AR, you have to put yourself in the shoes of the user and say, okay, the aircraft is here. I need the technician is going to be going from this angle, so I need the instructions to float in air here. Of course, they can move them, but we give them a default placement. And for that, the WorkLink is a perfect platform. As a software, as a vendor, I must say we also have a great relationship with the vendor itself. As robust as the software is, we find something that could be improved, especially in the workflow. Not so much the technology of graphics and 3D, but the workflow, like releasing work instruction is a very stringent process at Northrop. We have peer reviews and really very formalized release process. So we worked with the vendor to incorporate this stringent workflow in the software, and they worked with us. And very quickly, we added a role called a peer reviewer role that can see things and make notes, annotations, but not modify the models. So the vendor is also has also a great is also a great asset for us, a great relationship with the vendor.
Yeah, definitely. I mean, and something else I want to touch on too is you mentioned being able to reuse those 3D assets. So you've built a really great digital ecosystem within Northrop to be able to use those existing assets, optimize, convert, repurpose them. That's something we talk about. I mean, the whole purpose of Ventana is to help people do that because we saw so much waste. And so that's huge that you've been able to build this full, scalable, more automated solution with the right approval workflows that are needed. So that's great. And, obviously deploying all this at an enterprise level comes with really unique challenges. What were some of the biggest hurdles your team faced during the deployment process?
So we had many challenges, but I must say the team has been exceptional. I mean, I have so much respect for these young engineers, like thirsty for innovation, as much as for our management who removed all the roadblocks along the way, as well as for our executives who provided funding and sponsorship for the project. So we did have many challenges. I must say we address them all. I mean, at the end of the project, we release a robust industrial-grade AR work instruction system. So some of the challenges we faced were, for example, how to securely connect our HoloLens headsets to our enterprise network securely. We work with our cybersecurity, our networks partners at Northrop for that. And even with our partners at Microsoft, in many cases, we're the first customers of Microsoft or s2ep1 to achieve connectivity or use some features. We are the first to deploy WorkLink, first at Northrop to deploy the WorkLink software on our AWS cloud servers. They got resolved. We were the first to manage HoloLens headsets on the Microsoft mobile device management platform. It's called Intune. And we were the first to publish through the new workflow we created in WorkLink. So these were like industrial challenges we really resolved. But what I'd like to point to also is we had a hard time at the beginning justifying a project and showing the benefit of a project for a system that didn't exist. So people couldn't see it. It's hard to sell something that you cannot see. So for this, we partnered across different aerospace disciplines to create a little demonstrable prototype. And once we let executives wear the headset and see the holograms on the aircraft and understand how it helps the assembly of the aircraft, we kind of passed that hurdle.
Yeah.
On the shop floor, yeah, sorry, go ahead.
Oh, I was just going to say, yeah, I mean, it takes so much significant infrastructure to really set up an enterprise grade AR system. So you've got the hardware and the software. How were you able to calculate the ROI for all this to prove? You started with that proof of concept, to your point, to try and show people, which is so hard to do. But how did you go about calculating that ROI to get approval to really roll this out?
Yeah, it was hard to do, and we got a lot of pushback, and we had to validate our findings a lot. So regarding the ROI is pretty much a cost-benefit analysis, right? So on the cost side of the equation, we really detailed our costs very finely. We were pushed to do that by our finance partners, of course. And so pretty often we say, okay, the headset costs $3,000. So pretty often people came to us and say, oh, that's all it costs. So I have a project and it may be 10 headsets, so my project is going to cost 10 times $3,000. That's the cost of my project, $30,000. And really nothing can be further from the truth, because the cost of the headset and the headset itself is just the tip of the iceberg in an enterprise, in a production AR work instruction system. You have to take into account the cost of just the software. The licensing for the software that runs on the headset is almost as expensive as the headset itself. So that's already more than the hardware. The cost of hosting your system on servers, the cost of the licensing for the server side software, the cost of authoring, because when you create AR content, you need to author. So for us, we found that it takes about 40 hours average to create an AR work instruction job. So you need those 40 hours have a cost. It's like pretty highly paid manufacturing engineers who spend the time. The cost of maintenance, because even the aircraft itself, the design can change, so engineers need to go back and change the work instructions. So there are also ongoing costs. So all these costs we took into account. And again, it's much more than just the headset. So when we give a demo to people, they say, "Oh, it's great," and then they say, "Yeah, can you implement here?" And at the beginning, we had to say, "No, this is just like a file loaded on your headset. There's no like infrastructure around it. We can't really deploy anything." But now with having deployed all these components of the system, we can confidently expand our base and deploy more jobs. So that's on the cost side. On the benefit side, we look at them along 3 dimensions: at the frequency of the job, the complexity of the job, and the staff who are going to execute the jobs. So frequency of the job, as I just said, the integrated assembly line produces 1 center fuselage every 30 hours. So that's a very fast clip. So if we create 1 job in AR, and it's going to be used every other day, you're going to use it like maybe, 150 times a year. There's a great return on investment. If you save half an hour every time you use it, and you just invested 40 hours, you're going to spend 100 times half an hour over the first year, and then it's going to keep giving. Great use case. If your frequency, say you're building a spaceship or an aircraft carrier, and you're building 1 every year or 1 every 10 years, and you create AR content, it's not going to be used that much, and your ROI would be much lower. So the frequency of the job matters a lot. The complexity also matters. If it's a very simple job and there's just one piece to fit in the aircraft and it's very clear how it fits, there's not much help from AR. If it's a more complex job, and sometimes the same part could fit several ways, but it needs to be assembled in a precise orientation, then AR can be very, very helpful. And there's also always this balance, or this fight between bean counters, like finance, and production, right? Because finance looks at the bottom line, and they'd rather save 5 minutes 1,000 times than save 1 hour 10 times. But on the shop floor, they said, this 5-minute thing is very easy to do, and if I do it 1,000 times, after the 20th or 25th time, I'm going to remember. I don't need so much help. I need help on the complex jobs, and more complex jobs sometimes are not as frequent, so they don't yield as much benefit. So there's this balance to strike between complexity and frequency, and we really had to manage that balance in the jobs we selected to have AR on the F-35 assembly line.
Yeah, I mean, that's really smart because yes, of course, like frequency, you're going to be able to rack up those numbers, but at frequency, people generally learn. But starting with something with a high volume to at least prove the high ROI to set up this massive enterprise infrastructure makes sense. But I was talking to another manufacturer recently, and they have one specific, very complex process that happens maybe once a year, but there's only one engineer that does it in this huge factory. And so with that, it's like if that person calls out sick, God forbid anything happens to them, they're screwed. So in that case, it's like the risk and cost of if they had to shut the whole factory down because this one person couldn't be available, right? So there's a lot of...
And people, you're right. People are important too. I think the staff is important too for us. We notice different people approach the system differently. It's especially based on seniority, not so much on age, but seniority. Like if someone's been on the assembly line for 7 years and someone is fresh out of training for 7 days, the more senior, and they could be the exact same age, but just different seniority, different
Mhm.
people will approach the more senior technicians will not need as much hand holding and guidance from AR. The newer technicians will. So the people definitely enter into this equation of ROI and adoption.
Yeah, no, that's great. And one thing, we have talked about is, faster onboarding, reduced defects, improved cycle times are all key benefits. Are there any specific metrics you can share that you all have seen with using AR?
Oh yeah, we've seen most of those benefits. I cannot share specific numbers, but I have some qualitative observations here. So, for example, AR definitely helped us reduce defects on the line because, again, it shows the finished product to the technician as they are assembling the product. And reducing defect reduce rework, and rework is very costly. You need to undo things, redo things, costly in terms of labor. It's long to do. It could be even costly in terms of material if you need to scrap something and replace it. And no part of the F-35 is cheap. So
No.
avoiding rework is a great benefit. Of course, it improved cycle times because there's less travel time between the aircraft and a computer to look up work instructions or things like this. There's less time spending if you're holding a paper or a tablet, less time putting your tablet down, picking it up. So it does improve cycle time, which is the time the technicians take to do the job. And we've
Yeah,
seen
that's
we've seen
great.
similar product at Northrop across many programs. F-35 is one example. I know that on the E2D program, they racked the same benefits. They developed an AR system that's combined with predictive analytics, and they also got great benefit from that in terms of insights into the performance of the product, even beyond manufacturing, like during its sustainment life. Other benefits we've seen is VR. We use virtual reality on the same headset on the HoloLens, but we can do VR for training. So there's no aircraft in front of you, but you can still practice following work instructions and executing jobs with AR. So that's also something we use, and that's helped us streamline our like improve the efficiency of our training.
That's great. And you mentioned, the various levels. It's not about the age of the technician. Often people assume young people will be more open to tech, but that wasn't what it was. It was whoever was newer was a little more open to it, which was interesting. What strategies did you use to accelerate the adoption of the headsets by the workers and have this long-term success? Because that change management is a huge part of it.
Right, it is. So adoption, I think we started with adoption at our executive level because we needed executive buy-in into greenlighting the project. And for this, it's pretty easy. We had a demo on a headset. We invited executives to come to the shop floor, put a headset on their head. When they see the instructions, the holograms on the aircraft, they are bought in and they supported the project right away. That's how we got great buy-in from upper management and also like shop floor management, engineering management, all our middle management partners. On the shop floor itself, for the technicians, we we didn't designate. We found champions. So, like you said, like New York folks are more savvy to use the system, and some folks just emerge as champions. They like using the system. They told their coworkers, okay, look at what you can do. I'm doing this, and they show it around. So we didn't pick champions. They just emerged from the teams, and they were great at promoting the product and increasing adoption, accelerating adoption, I would say. So at Northrop, we also have a proven method of staff development. We have what's called our A-Star Academy. A-Star stands for Aeronautics Systems Training and Advanced Refinement academy. So it's a 20-week program that develop new recruits that come into our workforce, and we made a point to add an AR portion in the curriculum. So when new recruits take the training, they also train to our AR work instruction system, and they can try it and say it before they even hit the shop floor. So uh, they really hit the shop floor, the ground running, and use the AR system to their benefit on the shop floor.
That's great, and that training is essential, and just exposing people to the technology because, I've been in the XR space for a really long time, as I'm sure so have you, and it's like you forget people have never even tried a headset before most of the time, right? And it's so essential. You did that tops down and bottoms up approach for adoption. So top down from executives get the budget, which is essential, but then the bottoms up is just as essential to make sure people are actually using the technology and leveraging it, right? So now that you have this adoption really across Northrop Grumman, how do you see AR evolving on the shop floor over the next 5 or 10 years?
So the AR technology is going to evolve. There's no doubt it has to, even like forced by the Microsoft move. I think we have headset that will be more advanced, like lighter in a form factor, better battery life would be great, and that's coming because batteries. I mean they power our cell phones, our all other devices. So that's definitely coming. Performance will increase both on the headsets and on the server. So we will serve better models like that will look more natural, like curves will really be curves, not like a set of line segments. Better fidelity, better alignment to physical products. Right now, the alignment is the big topic, and our system aligns great with the product, but it can always be improved, and future system need to keep that alignment to the physical product. That's the crux of AR, and also integration. We want to integrate systems. For example, integrate AR with our Internet of Things, IoT devices. We have sensors everywhere that sense temperature, pressure, humidity, whatever it is. So if you could look at a product and say, okay, this is a hot area, this is a cold area, this is how I'm going to work in AR, that would be great. So integrate with all these IoT sensors, and of course integrate with our enterprise systems. If I'm completing a job in AR, I want to be able to say, okay, task done, and then have this reflected in our enterprise systems of records. The Scope AR Worklink product already does the beginning of that. We can mark things complete, so we need more integration to carry these updates all the way to our systems of records.
Yeah, so your project management software knows, all that happened. That makes a lot of sense. And something we haven't really talked about yet is digital twins. They play a really critical role in advanced manufacturing, which is slightly different than the AR that we've been talking about to date. How is Northrop leveraging digital twins across your digital ecosystems?
Yeah, so I think it's more than just digital twins. It's really, like you say, the whole digital ecosystem. We're very proud of our digital engineering ecosystem. It's a suite of interconnected systems that track the product from design through manufacturing, through even sustainment. And it also connects different stakeholders, not just engineering, but engineering can collaborate with manufacturing very early on in the design stage. On one system in our Pathfinder program, we found that just the collaboration between engineering and manufacturing, it cut down the engineering rework dramatically. Typically, on a typical program, once engineering reaches the manufacturing stage, there's a typical like 10 to 15% engineering rework based on manufacturing feedback. On that program, they had less than 1%. So we went from 10 to 15 to less than 1% of engineering rework. So yeah, our digital engineering ecosystem has great benefits that we're already seeing. It also connects different stakeholders, not just at Northrop within engineering, manufacturing, sustainment, but with our partners, our customers. We had government engineers access our digital engineering ecosystem to give us feedback and certification. We can connect with our suppliers, our partners, like other industrial partners. So it's been a great asset, and that digital engineering ecosystem is used in over 160 programs. So we in F-35 as we're a big program. We're one of them, and to me, AI is just it just displays it renders, if you will, what the digital thread has. So when a technician goes up to one aircraft, if they are assigned a job on one aircraft, they can scan a QR code with their headset. The job they see is specific to that unit. It's not like a generic job. Like we say, we have different variants. Even within variants, we have sub variants. It's a pretty complex typology of products, and AR renders that digital twin. So we know this is aircraft XYZ, number 1 through 3. We're gonna show the technicians the instructions for this specific aircraft and its specific configuration.
Yeah, no, I love that. And you mentioned the digital thread, which we talk a lot about at Ventana of, okay, you start with engineering, but those digital twins and 3D assets are only as valuable as they can travel through the life cycle of the product. And really, to your point, securely connect the internal stakeholders and your vendors and your clients and let everyone collaborate. So that's amazing to see you guys have really stood that up. If you could improve or add one capability to your current system, what would it be?
So I'm between two, like I said, performance and connectivity. Uh, I think I would vote for connectivity because performance is a given. I know future devices are going to come with better tracking, better batteries, better richer scenes and experiences and everything. So I would focus on connectivity. It can be like built in from vendors. The products can already connect. I mean, WorkLink has webhooks to connect to other products. There are APIs we can use to connect to other products. Or we also build connectivity internally to be part of our digital ecosystem, and that's something that streamlines the workflow and makes the work easier for end users. So I would vote for enterprise connectivity, be it IoT on the shop floor, that's Internet of Things, or again enterprise systems on our backends.
Yeah, no, that makes a lot of sense. And this sounds like a lot. It's probably a little overwhelming for people new to AR. What advice would you give to organizations just starting to explore AR for manufacturing and assembly lines?
Sure. So I would say start small and be agile all the way to a good production system. So when I say start small, pick maybe a couple jobs that are representative of what you do in your shop, and you can try to build work instructions for these two or handful of jobs, and then that'll help you not just demo to other people, but also evaluate your own content yourself before you scale out to production, and then demonstrate to your stakeholders and stay in touch with your stakeholders, especially the users who are going to use it, but all stakeholders. Cybersecurity may have something to say, networks may have something to say, our server administrator may have upgrades and things to do. So stay close to all your stakeholders, and then also be agile. I mean, you're going to iterate. When I say agile, I mean in a Scrum sense of the term, or Kanban sense of the term. So you're going to iterate through sprints. You're not going to have a product right away. So it's okay to have a few sprints of just laying out the foundation. It's a long road to a robust production grade system, but iterate, be flexible to adapt to any constraints or roadblocks you may meet, and then gradually you will get to a usable production system.
Yeah, that's great advice. And last question, what are you most excited about for the future of AR and digital twins?
So what I'm most excited about, I see more. I mean, I think it's more than just AR. AR is an example of technology. Again, that's part of our digital ecosystem. And that ecosystem for us is driving performance, it's driving collaboration among stakeholders. It's connecting our own stakeholders with external partners. When I look at AR in the future, I think we'll be better able to use it if it's more ubiquitous and pervasive. Because if everybody is using AR, then you can have many more use cases. For example, in aerospace, in our shop, we have a lot of placards and lines to delineate areas and things like this. And sometimes they change, and sometimes they don't. But they are just like physically posted on the shop floor, on the floor, on the walls, everywhere. If everyone who's using AI, you could let go of these posters and placards and lines and and just informational assets, and just see, okay, now I know I'm in an area that's fog level 3. I know here I need to wear safety glasses or whatever. So when AI becomes more pervasive in the shop floor, it'll open up a whole slew of use cases. Now, beyond our industry, I think the same thing applies if you're, say, landing an aircraft on an aircraft carrier. The aircraft carrier needs to light up their deck and to show a landing strip. But if the pilot can see it in AR, there's no need to light up the whole deck for an aircraft to land. So
Yeah,
that's something, yeah, and that's something that could be pretty useful. Not lighting up the whole deck of your of a ship. So,
yeah. And
uh,
stay
uh,
incognito for sure.
yeah,
Awesome.
so that's another like beyond my specific industry, and even beyond that, beyond aerospace, just driving cars. Well, I just got a new car recently, and uh, I can see stop signs and speed limit signs in my car on the screen. I don't need
Oh
a
yeah,
metal.
it's
I
great.
don't need
Yeah,
metal poles to be planted in the ground with the word stop on them to know I need to stop. Right. So
yeah.
if all the drivers were uh, had access to AR capabilities, we could let go of a lot of like stop signs, speed limit sign, a lot of signs, even the sign that says LA 55 miles. I mean, I think that's already obsolete with everybody having GPS, but we
Yeah,
could, yeah, restore much nicer landscapes around our roads. So
I
many
love
more
it.
use cases when it becomes more pervasive and more ubiquitous.
I love it. Well, Michael, thank you so much for joining us. It was so great to learn more about how Northrop has really not just used AR for training, but yeah, deployed this entire digital ecosystem to connect the organization to the data they need and in the places they need it. So thank you. And where can people find you if they want to reach out?
Sure. So I'm on LinkedIn. My name is Michael Hayat, Hayat, and you can email me at Northrop Grumman. That's my first name, Michael dot Hayat, Hayat at ngc.com. NGC like Northrop Grumman Corporation.
Awesome. Well, Michael, thank you so much. Talk to you soon.
My pleasure. Thank you.